Good evening, everybody. Thank you for joining us at this weather forecast decision-making workshop. It's great to see nearly 800 of you join this session tonight. My name is Chris Kidd. I'm the Director of Astral Aviation Consulting Ltd, and we're an aviation consultancy that have been contracted by the UK CAA to provide a bespoke safety campaign on behalf of them. However, I'm pretty sure over 800 of you haven't come to see me tonight. You've probably come to see Simon. More about him in a second. Firstly, we're also joined by Matt Lane this evening, who's Head of Training for RAF Sport Aircraft. Hello, Matt. So if those regulars, you'll know Matt. He's an active single engine and multi-engine FI and flight examiner. Also, we are joined by Dr. Simon Keeling.
Hi, everyone.
He is a fellow of the Royal Meteorological Society, a one-time TV weather presenter. You can find him online. We did that earlier, so please do. And the founder of Weather School. Weather School teaches pilots how to confidently interpret and forecast the weather so that they can get the maximum from flying time available and to increase flight safety. You can find more about Simon's courses at weatherschool.co.uk, more of which later. And in his own words, he's a self-confessed weather anorak, which I'm sure will come out later on. Welcome to you both.
Hi, Chris.
Brilliant. So for those of you that are new to this, I would really want your feedback and also want you to ask questions as we go. So please do put any comments or questions you might have in the chat box, and then we'll pick them up as we go. There are three parts to this this evening. In section one, we're going to cover off what MET products we recommend GA pilots use and how to use them. Simon's going to do that bit. Section two, we're going to cover off how to approach the weather forecast decision making. Matt's going to do that. And then finally, in section three, it'll be time for Q&A. And the aim of this, of course, is so that you all leave more informed about what MET products should be used prior to flight, how to correctly interpret MET briefing products, and then ultimately leave being more confident in making weather-based go or no-go decisions. As I've already mentioned, I really do want this to be an interactive event, so there will be a number of polls that will pop up for you to interact with as we go. And again, please do put those questions or comments in the chat box as we go, and then I'll dip in and out of those as we go through the workshop. So that's enough from me. Without further ado, I'll hand over to Simon for more on recommended MET products, how to use them to our best advantage. Simon, over to you.
Thank you, Chris, and good evening, everybody, and thank you for joining us this evening. Special thanks to Astral Aviation Consulting for asking me along, and to the CAA for supporting this evening. There's lots to MET. Don't get too daunted by it. That's the first thing that I would say to you. Best thing with MET, stand back, take a broad view. So without further ado, let's start with a poll just to get the old brain juices flowing a little bit. And see how you get on with this one. If you see this on a chart, so 015-030/XXX in the cloud section on form 215, what does the XXX mean? Now, is it that the cloud is very thin? Is it that the forecaster is unsure of the cloud tops? Forecasters are never unsure. It's the weather that goes wrong, never the forecast. Does it mean something very rude, or does it mean that the cloud tops are above 10,000 feet? Have a go. See how you get on with that one. So those are your four options. The cloud's very thin, forecaster is unsure of the cloud tops, something very rude, or that the cloud tops are above 10,000 feet. Let's see how you've got on with that one. Let's see what the results show. Okay, so I'm just reading down them here now, and well done, the majority of you. You've got your weather heads on today. 83% of you saying that the cloud tops are above 10,000 feet, and that's exactly what that means. So well done for getting it correct there. Let's just get into things and just see what more information you can get from form 215. So how do you go about understanding the MET on the actual day that you want to fly? What should you use to do it? There's multiple apps available at the moment, and they make reviewing TAFs and METARs and the general weather situation pretty easy. However, whilst useful, many of these can be easily misinterpreted, and we do kind of fall into that gap of thinking the sexier that the app looks, the better the weather forecast is going to be. That is not the case. So you can easily misinterpret those, particularly if user limits have been set. And of course, all of them make reviewing the big picture of the weather quite challenging. So therefore, I always recommend going from big to small. And this is what I mean about taking a broad view of the overall picture of the wind and weather systems that affect the whole country before we hone down into our specific airfield or local area. So doing that is going to help you be prepared for any weather changes that, without sort of looking at the overall weather for the day, you could get caught out by. That overall view is really important to see. So the best place to start is with two specific products that are produced on behalf of the CAA by the Met Office. So that's Form 215 and Form 214. Now, to some extent, these charts, I think, have kind of fallen out of favour a little bit, because it's far easier, isn't it, just to pick up your phone, tap in the information you want to see, and it's instantly available. But trust me, 214, 215 are the best forecast sources that are out there for the weather on that particular day. So let's ask you another question then, and let's see how you get on with this one. So what I want you to do is to tell me what the 215 actually is. What is it we're looking at when we look at Form 215? Is it the UK low-level spot wind chart? Is it the high-level aviation area forecast? Is it the low-level aviation area forecast? Or is it the UK high-level spot wind chart? Which one of those is it? Is it the UK low-level spot wind chart, the high-level aviation area forecast, the low-level aviation area forecast, or the UK high-level spot wind chart?
And due to the fact that I have an inability to operate PowerPoint, I'll give you a huge clue by putting the chart on the screen.
That's all right. All the best game shows do this. There's no money involved, so we can do it anyway, Chris. So, which one do you think it is? Go on, as Chris just said, it's pretty obvious, isn't it now? Go on, let's see how we got on there. Let's put the answers up for you and see how we did. Yeah, absolutely. There we go. 91% of you saying it's the low-level aviation area forecast. I'm impressed. Well done, everybody. So both 215 and 214 are Met Office products that are available through the Met Office Aviation Briefing Service. It's free to sign up to, and these charts are completely free of charge. They provide a wealth of information on aviation weather. So I recommend you go and sign up, if you haven't already, to the GA Briefing Service through the Met Office website. Okay, so let's look at Form 215 now in more detail and the information it portrays. Now, I know that for some of you, I'm going to be teaching Granny to suck eggs here, but hopefully I can give you a few hints and tips that perhaps you've forgotten along the way, or perhaps you never knew. So when we look at Form 215, the whole thing can look very daunting, can't it? I mean, me as a forecaster, I look at these things every single day, and wow, there's a lot of information on that screen. And very often, as I say, it's easier just to go and grab the phone and look at what the apps say. But this is the chart that's going to give you the information that you need to fly. Now, don't worry about it being daunting, because, as I say, once it's been explained to you, it's pretty easy then to comprehend. Trust me, let's just break it down. So easiest thing to do here is to start from the left and work your way right as we're looking at the chart. So let's start off with that left-hand block. And the most obvious part of that left-hand block is the frontal chart. So that frontal chart that we see there on the left-hand side, we're going to talk about in just a moment. Below that, there's a couple of other boxes. One of them is the decode of various different parts of what the boxes on the right-hand side are saying. And the one at the bottom is some housekeeping from the Met Office. Most importantly there is the time of issue. So you see down at the bottom of the screen there, it tells us what time this forecast was issued. So in this case, it was the 9th of the month at 0308 Zulu, or UTC or GMT. Remember that Zulu, UTC, GMT, all exactly the same thing. Now, something that's very important here is that the document clearly states that the front's zones chart, that's the one shown to the left, is valid for a specific time. And you can find that time of validity by going across to the right-hand side, and you see where it says forecast weather below 10,000 feet. Come down the next line down, and to the right-hand side it says fronts stroke zones valid at 09 1200 Zulu. Now it's really important to take note of that, because that's the time that chart is valid for, not before and not after. That chart is valid for midday, and the zones are valid for midday as well for that specific time. You might be flying at 0800, but that chart is still valid for 1200 UTC or 1200 Zulu. So let's have a look at that frontal chart in more detail. Now, on here, we've got warm fronts, we've got cold fronts, we've got occluded fronts, and we've got troughs all marked. And through these, you can see that we've got arrows. So through the actual charts themselves, we've got arrows. Let me just see if I can highlight that for you. So these are the arrows in here that I'm referring to. One there, we've got another one there, we've got another one there, and a few more across the chart. So what do they refer to? They refer to the speed of movement of those fronts. And remember that 1 knot equals 1 nautical mile. So by knowing the speed of movement of the fronts, we can knock it on by whatever that distance is. 25 knots would be 25 nautical miles in an hour. And we can have a rough estimation as to where those fronts may be after the time of validity of this chart. And of course, we've got these strange scalloped areas on there as well. So these sort of marks that you see down here. So they're denoting the areas of weather, which we're going to come on to in just a moment. Someone actually said to me at a recent weather school that their instructor told them that where the lumps of the scallops point to was better weather. That is complete nonsense. It is not true. So it's the first time I've heard it, but I'm going to stop that pervading the weather, the flying schools now, because that is not true. Where those lumps are doesn't point to better weather. It has no bearing on the weather at all. So each of these areas contain a letter. So you can see the letters just in here. We've got A here, we've got B here, and they refer to different areas of weather. So let's now just get over to the right hand side, and you can see here that we have 3 columns: 1, 2, 3, and 4. So the first column here refers to the area, and those are the areas marked on the frontal map. So where we've got area A here, that refers to any of the areas marked on here as A. Okay, so that's that first column is referring to those areas. And actually, as we notice on that frontal chart there to the left hand side, there's actually a couple of areas marked A. In fact, there's 3 areas marked A. So the next column, so the column that we see down here, that next column tells us what the forecast of visibility and weather is likely to be within that particular area. So everything across here refers to area A. Now, what this is telling us is that in area A, or any of those areas marked A, the predominant visibility is 40 kilometers. We then have the detail of the weather within those areas. Now, just a note on the visibility always goes from the best visibility down to the poorest visibility. So as we go down through this column, we'll go from the best visibility down to the poorest visibility. So let's have a look at what we've got on here. First up, it says ISOL. So that means isolated. So it's telling us here that we've got isolated conditions within area A, although sort of frequently, and we can see that also marked in here, occasionally, frequently within area A1. So occasionally, frequently within area A1 here, and close to the fronts in area A1. So that will be close to the fronts that we see in there. The visibility is reducing to 7 kilometers in showers. So SHRA probably all fairly familiar with that. That means that we've got showers of rain. And incidentally, these little dots that you see here, this is a carriage return statement. So it just means keep on reading to the next line. Now, however, within our area A, there are going to be isolated areas of 4,000 meters in mist, and that will continue over land, which is the LAN, until 1100 Zulu. Now, if you're thinking about, well, how do I know what these abbreviations actually mean? If you go to the Met Office Aviation website, scroll right the way down to the bottom, there's actually a section there that says abbreviations. Click on that, and there's a list of alphabetic abbreviations. Now, not only that, but along the fronts in Area A, there's also going to be isolated visibility of 3,000 meters, and that's going to be occasional in Area A1. So this is telling us that, yeah, you'll get 40 kilometers in many areas generally, but there are going to be these isolated areas of 7 kilometers in showery rain, but also some mist over land until 1100 Zulu, and then isolated 3,000 meters in heavy showers of rain, mostly close to the fronts. So it's telling us that wherever we're close to these fronts in Area A, we are probably, or we could see isolated heavy rain, heavy showers close to those fronts. It's also saying that we'll get isolated occasionally in the northeast, 2,500 meters in heavy thunderstorms, rain, and possibly hail in Area A1. So within this area, there is the chance of seeing heavy thunderstorms with rain and hail, and even isolated 1,200 meters in snow over mountains. The MON means mountains. So we've got isolated 1,200 meters in snow as well. So basically, this system is throwing everything at us bar the kitchen sink. There's a lot of weather that's going on in there. Not only that, let's come down again. So 200 meters in fog and freezing fog, overland until 1000 Zulu, isolated again. So there will be these isolated areas where we could find 200 meters of fog or freezing fog overland until 1000 Zulu. And then we get down to the bit here, which tells us about turbulence. So here we're saying isolated moderate turbulence in the far west. So in the far west, we could find isolated moderate turbulence, and also moderate turbulence with occasional severe turbulence in Area A1 in the northeast. So in the northeast of that area, and also isolated hill fog. So there's a lot happening there, but now that we've read it through, we can kind of say again, okay, well, generally within Area A, so within our areas A, I'm just going to concentrate on this one first of all. Within our Area A, we do have 40 kilometer visibility, but close to the fronts, and generally isolated close to the fronts, but frequently close to those fronts in Area 1, we've got 7 kilometers in showery rain. We've got some mist over land until probably around 1100 Zulu. And then isolated and occasionally over A1, we've got 3,000 meters in heavy showers or rain, mostly close to the fronts. And then isolated, but occasional in the northeast, 2,500 meters with a risk of some thunderstorms and hail in Area A1. And then isolated 1,200 meters in snow over any mountains. And then we're thinking about the chance of 200 meters isolated fog or freezing fog over land until 10 o'clock, and then occasional moderate turbulence in the far west, and moderate turbulence, occasionally severe turbulence in Area A1 in the northeast of Area 1, particularly with isolated hill fog. So a lot of information on there, much related to the weather in proximity to those fronts. So next we come to the clouds section in here. So we're going to come to the cloud box in here. And again, it can look very daunting, but it's easier if we just break it down. Now, we're going to look at Area A again. But firstly, first thing to note is that every height that we see on this chart, so every height on this chart is above mean sea level. Okay, and the heights go, the cloud heights go from the highest to the lowest bases. So you're always going to go from the highest cloud down to the lowest bases. Now, within this area, we've got isolated, but near the fronts, it's occasional. So occasional is more frequent than isolated. We've got scattered to broken altocumulus. So this is medium level cloud. So we've got scattered to broken altocumulus cloud. Now, within that cloud, we have moderate icing, and we also have moderate turbulence. Now, if you're ever unsure of these symbols, all you need to do is to look down to the box here at the bottom of the frontal chart, because they tell us what those symbols are. So within that altocumulus, we're going to be seeing moderate turbulence and moderate icing. The bases of that altocumulus cloud are 8,000 feet. That's what the 080 refers to. Tops are above 10,000 feet. There's the XXX that we started off with at the beginning. Now, it's also telling us that we have areas, and these areas are widespread close to the front and in area A1 of scattered to broken cumulus and stratocumulus cloud. So this is where kind of knowing your clouds again becomes quite important. And within that cumulus and stratocumulus, we have a risk of moderate icing, and we have a risk of moderate turbulence as well. Now, something here that's really important is that the bases are between 1,500 and 3,000 feet, and the tops of those clouds between 6,000 and above 10,000 feet. This chart only goes up to a maximum of 10,000 feet, so anything above that is always marked on with that XXX. Now, I've also, just from doing some research for this, learned that a lot of pilots get quite confused with this statement on the Form 215, because they think, well, some of them think that this is referring to a base and a top of 1,500, top of 3,000, base of 6,000, tops above 10,000. So almost 2 layers of cloud. That's not what it's doing. What this is doing is referring to a base, which is here, and a top, which is here. It's a single layer of cloud. And again, it was just some research I've done, and talking to somebody you may know called Irv Lee, who runs Higher Plane Aviation. Irv really steered me into this and said that's something he's noticing with a lot of students, that they're confusing that these are actually single layers of cloud, not a description of 2 layers of cloud. So don't fall into that trap. It's easy to do that. And then we have isolated, occasionally in the northeast, cumulonimbus cloud, CB, that's the one we all want to look for, bases of 1,500 to 2,500 feet, with tops above 10,000 feet in area A1. So again, this area seems to be very active. It keeps cropping up. And then isolated, but occasional over upslope. So this is the upslopes of hills, scattered to broken stratus cloud, and immediately stratus telling us it's low cloud. And indeed, there's the base, 700 to 1,200 feet, and tops of about 1,500 feet. And then isolated, scattered to broken stratus even lower, with a base of 300 to 700 feet and a top of 1,500 feet over the land until 1,100 Zulu, with a base perhaps of the surface, which is what the 000 refers to, in fog or freezing fog. So again, it's given us a heck of a lot of information in a relatively confined space. But effectively, what this is suggesting to us is that there is a layer of cloud above that we may see from the surface, probably altocumulus, and that we're going to get big areas of scattered to broken cumulus and stratocumulus with that base of 1,500 to 3,000 feet, and the top's probably 6,000 feet. So we've got a good sort of 3,000 to 4,500 feet depth of cloud minimum, but then some of those tops are going to go up above 10,000 feet. And we also just need to be aware that there's the risk of some QNIMs with some tops above 10,000 feet in area A1 particularly. And we just need to be aware that on these upslopes, we could be seeing 700-foot bases to 1,200-foot bases with tops of 1,500 feet. So this kind of points to the risk of some hill fog in there. And of course, hill fog was mentioned under our weather section. And we should just be prepared for some even lower stratus cloud over land until 11 o'clock. And of course, that 11 o'clock matches with our 11 o'clock for the risk of mist and also for that risk of fog that we saw earlier on. So we can get this big view of weather by looking at form 215 and the cloud, of course, as well. Now, the final column here is our freezing level. So this is telling us that in area A, freezing levels are probably going to be between 2,500 to 4,000 feet. Now, remember that freezing levels are always just an estimate because they will vary naturally with the weather, but also we should be making adjustments as pilots for freezing levels varying because of the amount of moisture that there may be in the air at any particular time. But certainly this is a great guide for where we should expect to see our freezing levels. So you can see by how methodically breaking down each of the zones, reading them through can give you a much better overall idea of the forecast ahead. Now, yeah, granted, I've kind of spoken through this and taken a bit of time doing it, but doing it yourself, getting used to it, does take more time than simply flipping it up on an app on a phone. But the depth of information you get from Form 215 is there, it's greater, and it's much safer for flying as well. So what I'd urge you to do, print these off, practice. The easiest thing to do, print them off, compare them to what the weather's doing outside at any particular time for the point that you are in the area that you are. You will be amazed at how rapidly you learn your way through these charts. So that's Form 215. Let's just have a quick look at Form 214. And I'm conscious of time, but 214 is a bit quicker. So firstly, let's just have a quick poll. Now that you've listened to me for a while, let's get the brain going again. On the chart that you see in front of you at the moment, that Form 214, what I want you to tell me is what the forecast 2,000-foot wind is specifically at Liverpool. So I want you to tell me what is the forecast 2,000-foot wind specifically for Liverpool. Is it 260 degrees at 20 knots? Is it 250 degrees at 20 knots? Is it that there is no forecast for Liverpool? Or is it 210 degrees at 25 knots? So you've got 4 possible answers there. Tell me what the wind is specifically for Liverpool. I'll give you just a second just to have a look, and hopefully you can see that. Okay, see what you think. Right, let's bring up the results of the poll. Let's have a look and see what answers you gave. Okay, something 260 20 knots. Yeah, okay, fewer 250 20. No one's gone with a 210 25, or 2% have. And the majority, 42%, have gone with there is no forecast for Liverpool. So pretty close between 250 degrees 20 knots and there is no forecast for Liverpool. Well, the correct answer is there is no forecast on Form 214 specifically for Liverpool. So the reason for that is that the boxes that are here refer to the latitude and longitude given there. Okay, that's the point that these forecasts are made for. It is specifically for that location. Talk about that in just a second. So again, what we're going to do is start from the top of the chart, and this tells us that we've got a low level spot wind chart. And there's an important clue here because it says spot wind chart. Another important statement is made where the chart says forecast valid for 1200 UTC on the 9th of December and valid between 09 and 15. This is a spot wind forecast chart. It's actually the winds at 1200 UTC, not before and not after. So it's actually a little bit misleading, this chart, when it says valid between 09 and 15, because the forecast time is actually 1200 UTC, although we can make some adjustments for our airfields to get some guesstimates. So we should be very aware of changing wind directions, especially fronts are moving through, which can rapidly change speeds and directions. Now, onto those wind forecast boxes, and it's really vital to realise that these forecast winds are only for the latitude shown in the box. That's the central point of these. That is the point at which the forecasts are for. So these then show wind speeds and directions and temperatures from high to lower levels. So at 1,000 feet, at 52.30 north, 2 degrees 30 west, the forecast wind was forecast to be 230 degrees 15 knots at midday, and make the point that it is just midday, with a temperature of +4 degrees. And remember that these forecasts only valid for the point at which that box states. You have to make adjustments if you're going to go between the two. And also note that these heights are above sea level. So those are always above sea level. So if your airfield was 500 feet, for example, here, the 1,000-foot wind, if your airfield was 500 feet above sea level, the 1,000-foot wind actually refers to 500 feet above the airfield. So remember that only refers to the height above sea level. So again, print out 214, have a practice, have a look, and make the adjustments as necessary. But remember, the most important thing here, those boxes are specifically for the latitude and the longitude that's shown. Chris.
Brilliant. Thank you, Simon. Did I mention he's a self-confessed weather anorak? Now you know. Brilliant. So now we've covered 214 and 215. Let's move on to the second part of the workshop, where Matt will discuss how to use these products to help you in your decision making. Over to you, Matt.
Yeah, thanks, Simon. Thanks, Chris. Fascinating. I should never say that well, I can say it was on Zoom, so Simon can't reach me. But in my ATPL and my PPL exams, Met was always my most feared, hated exam. So I should never admit that, but there we go. Right. So as is tradition, let's start with another quick poll. So poll 4, if we could put that up, please. So this is how long do you, before your flight, should you begin looking at the weather forecast? So think about, what are we today? We're Wednesday. You know, we're going to go flying maybe this weekend. You know, how long before should we begin looking at the weather forecast? And this is subjective. This is not a pass fail right wrong answer. This is just a subjective thing that we want to get your thoughts on. So we've got 7 days, 72 hours, 24 to 48 hours, or on the day. So have a thing, like say it's Wednesday, going flying this weekend. When would you start looking at the weather? Let's have a look at the answers then, if we can have those up. 24 to 48 hours, or about 72 hours, seem to be the favorites. Yeah, I think what I would go for and recommend is 24 to 48 hours. Like I say, it's subjective, but we could say looking at 7 days might be a little bit too far ahead. If we leave our weather decisions to just on the day, maybe we haven't situated ourselves as well as we could have done leading up to the flight. So yeah, so what I agree with that 24 to 48 hours to go. So let's run with that, and let's call that phase 1, yeah, or phase 1. So it's a few days before our planned flight. Good idea to look at the weather and make a generalized decision. And what I'm going to suggest to you is this decision should be broken down into either we're going to continue, cancel, or make it a maybe. So next slide, please. So yeah, this is what I suggest you maybe the buckets you're thinking about in. So at this stage, all that good stuff Simon's done, but we really at this stage can be looking at the general synoptic situation, general likely weather conditions, and some of the sources we can get you can see there for Met Office app, TV weather forecast. These are all things that are using advanced computer modeling. So out for a few days out, they're fairly accurate generally. And at this stage, if we're looking that there's widespread rain, low cloud, poor viz, strong winds, this might be an obvious threat to our flying. And we might then be thinking about, well, I'm going to cancel it at this stage. Or we might decide, well, it's looking okay, it's looking really nice actually, so I'm going to make quite firm plans. Or we might be looking at the, well, maybe we're not entirely sure, we're going to have to give this some more thought closer to the time. Now, this decision, of course, as some people picked up earlier in the chat box, going to be heavily influenced by the nature of our intended flight. If we're going to be flying new, nervous passengers, an early decision to delay them for a better weather day might be the quite easy thing to do, might be the right thing to do. You know, let's not mess them around close to the day. Let's say to them, let's wait for a much better day. That might be an easy decision. But as some people highlighted in the chat earlier, if it was just a few circuits for yourself to keep yourself current, or just go solo in the local area, just have a nice little trip on your own, we might be more content to wait and decide on the day. But what I do suggest to you is that maybe decision outcome is quite an important one, because what it does is it allows us to try and avoid the confirmation bias human factors trap. So if we've already sowed that seed, that we've preconditioned our brain to think that our intended trip may have to be cancelled or modified, that's kind of good, because it makes us less inclined to fall into that it will be okay on the day kind of mindset when maybe it isn't. And it also gives us time to come up with some alternative threats or mitigations. So, you know, that long trip over the sea to France or whatever, when we can do that kind of thing, we might be thinking that's not a great idea. That might be quite a stretch. So it gives us a bit of time to think about having a backup plan. We might fly to a local airfield to meet up with a friend that we haven't seen for a while. So having those plan Bs ready and having those alternative thoughts ready is pretty important to us. So that's phase one. Let's have a look at how we then narrow it down a little bit to on the day then. So just go to the next slide, please.
Very quickly picking up on some of the chat before we move on to phase two, if
Yeah.
I may. Some really good stuff coming in from guys there. Some people talk about recording the BBC weather, Met Office channel on YouTube. That's a really good point as well. Use of XC weather. Yeah, so some great stuff going on in the chat. So thanks to everyone that's contributing there. All good stuff. And as Matt says, it's all about making that decision not on the day, you know, be that 48 hours or 72 hours beforehand. So just have a think about that. But yes, keep those things coming on the chat. Thank you.
So
right,
yes,
Matt, back to you.
Thanks. So on the day of our intended flying trip then, I suggest you're now going to look at honing it down into a go, no-go decision. Yep. And our information, as I've already alluded to, we're going to need to scope the information we're getting to make this decision appropriately. So if we're just doing a local few circuits, a local flight in a local area for our currency or whatever, the amount of information and the timeliness of the information that we might want to get might be very different to flying from down in the south of the UK all the way to Scotland to go and visit somebody for a long lunch and then flying back that evening or something like that. So again, the amount of information we're going to have to scope will have to be varied there as well. So let's have a look at some of the things that we want to get out of our weather information in order to help us make that go or no-go decision. So if we could have the next slide, please. So here we go. There's four real factors that I suggest you really need to base your decision making on: cloud base, visibility, wind, and weather phenomena. So with a cloud base, you need to look at what the likely cloud base and ceiling is going to be at different points of your flight. And what we're really after here is your ability to remain in visual conditions at a given altitude, and whether it's going to lower during the flight, whether it's going to force you down. And of course, when we're looking at this, remember, as Simon already pointed to, we need to compare the cloud height to figures at aerodromes with the surrounding terrain. Because those TAFs and METARs that Simon has already alluded to as well will give cloud levels in height above the aerodrome elevation. You know, a 1,500-foot cloud ceiling, it could be shrouding the tops of nearby hills or terrain that you want to get through or in or around there as well. And really, again, if I was going to give you something to try and hang your hat on, or a guide to see, you know, VFR flight with a cloud ceiling of 1,500 foot or less above ground level is where you really need to be thinking about paying special attention to terrain or obstacles. Okay, so that's a kind of figure that I would have in my mind. And VFR flight below 1,000 feet AGL generally is only suitable for circuits or very local flying in areas that you're quite familiar with, I would suggest to you. Moving on then to visibility, and we need sufficient in-flight vis to control the aircraft visually. We need to be able to navigate, and we need to be able to avoid other aircraft successfully as well. That's obviously a key factor in visibility. 215s, TAFs, METARs, they're all going to give you an indication of surface vis. But remember as well that the actual in-flight visibility can be a lot worse in the air because of haze, flying into sun. And remember from all your exams and things like that about slant visibility as well can be quite different to actual horizontal visibility in the air as well. We've all had those summer days that look brilliant on the ground, but once we get up there, it can actually be quite challenging. And another thing I'd like to mention here as well is, of course, VFR flight in Class G airspace below 3,000 feet AMSL and below 140 knots is legal with only 1,500 meters visibility. Yeah. However, if we're really honest about it, that's going to be very challenging conditions for VFR flight. And again, if you want to give a sort of figure that I would be thinking about, if the surface visibility is reported as less than 5 kilometers, that's going to be into very challenging territory for you. So that's something I'd be thinking about. You're going to struggle to have a good clear horizon and anything less than that. Wind, you need to look at the likely wind for all the runway directions you plan to use. So for example, I did a flight from Benson, from Brize Norton to Oxford to land away for fuel with a test student as well. One's got a north-south runway, one's got an east-west runway. Can experience quite different crosswind conditions as well. So make sure you have a look at everywhere where you're going and how the wind's thing. Crosswind landings, particularly in tailwheel aircraft, it's one of the more perishable piloting skills, especially when we've all been interrupted by horrible virus situations we all know about. And you may want to define your own personal limits. What may be comfortable for somebody might not be comfortable for you if you're new to the aeroplane or you haven't been flying much aloft as well. High winds aloft, not in themselves necessarily directly hazardous, but again, if you want some figures to hang your hat on, anything winds above 35 knots upper air, I think are pretty indicative of quite bumpy, turbulent conditions. So, you know, maintaining height, heading, navigation, it's going to be quite challenging as well. And also, don't forget, if you've got very strong headwinds up at height as well, you need to factor that into some of your fuel calculations as well. And then finally, weather phenomena here as well. Yeah, so there may only be prob 30s, there may only be prob 40s or whatever, but you need to really think about them and whether they could affect you as well. And things here I'm talking about: thunderstorms, fog, snow, icing, significant turbulence, these kind of phenomena. But it might be a really nice day, but they could happen. I was doing some night flying, put some really quite cool photos of it on my Instagram feed if anybody wants to look them out. Doing some night training, instructor training at Oxford a few weeks ago, and beautiful, clear, Cav-OK night, no wind at all. We thought it was going to be an absolutely stunning thing. Fog appeared because that dew point and temperature were very close together, totally unforecast actually, and that fog appeared. It was a prob 30 later on in the evening, well after we were going to be flying, and it appeared and it came on literally less than 15 seconds. We timed it, it covered the airfield. So, you know, and that was where that prob 30 in that TAF was giving us the hint that that might come in. So do look out for those things there as well. So very quick canter through some things to think about and maybe how to structure your planning. And again, it's all about, I echo Simon's point there as well, about going from big to small, just the same with your planning. So big a few days before, going down to the small detail to make that no-go decision. Thanks. Over to Simon again.
Thanks, Matt. Yeah, interesting you said there about the fog developing during your night flight a few weeks ago. I'm just wondering if the wind speed picks up a little bit during the flight. You know, it went from calm, you said that you got no wind. So I wonder if it picked up a little bit. That wind range between 3 knots and 7 knots, you know, absolutely critical for the formation of fog, because it just mixes things up a little bit, and you can get fog developed really quickly when you've got a radiation fog probability in the TAF. So something just to watch out for. If you see that wind coming up to between 3 and 7 knots, that's the perfect recipe for fog. just a little something there for you. Okay, so what's the best way to obtain the detailed information that we need to make our final decision to fly? And the best way to make your go or no-go decision is to use the products that you can see on the screen in this order. I think it is Met Office Form 215, so the low-level aviation area forecast that we've covered. I think you should have 214, so that's the low-level spot wind charts, using all the information that we've given you tonight. Select your areas. Remember that the wind boxes are for those specific points, not for the whole area of those boxes themselves. And look at the TAFs and the METARs for your base airfield, your local area, and your destination airfield as well. And just a word about this as well, because you may not have a TAF produced for your local airfield, but I can guarantee that if you've been flying from your airfield for a little amount of time, then you will almost be the best person to a certain local conditions. And again, you'd be quite amazed at how quickly you can start adjusting the TAFs to kind of fit your local airfield, particularly with things like winds. You'll know in what direction you tend to get more wind or less wind from. So you can kind of make those adjustments to the TAFs yourself, but it's those official METARs and TAFs that are key. And of course, we've not spoken about TAFs and METARs this evening. Boy, we've taken up enough time already, haven't we? But if you're not completely comfortable with TAFs and METARs, perhaps this is the time, as we get into the winter months, start having a look at the TAFs, compare it to the weather that you're seeing outside your window, particularly on bad weather days, and just kind of get yourself refreshed into what those things actually mean, particularly some of the more unusual weather codes that start to occur as we go into the winter months. It'll then be a lot easier for you to interpret them. So in terms of getting hold of them, mobile phone apps can provide very ready access to METAR and TAF data. And this can be especially useful when you're away from full internet Wi-Fi and only able to access mobile phone data. So you can get hold of that information on there. However, and this is a massive however, check the time and date of the published information and the validity period for your METARs and TAFs, and make sure that you refresh the page every single time before you review them, so that you're not using out-of-date information when you're planning your flight. Always make sure that you've got that information to hand. And something as well, just to have in the back of your mind when you go flying and when you're looking or considering weather information you're going to look at to fly. And this is what the CAA actually say about getting hold of weather information. Now, I know it's a big section of text here, but I think this is virtually the same as what's in the Safety Sense leaflet that you can get from the CAA website on winter flying. And yes, I know it's a bit of text there, so I'll leave it for you to read for a wee bit. But the most important part of this is that pre-flight planning should, as a minimum, include reference to regulated aviation meteorological products and information. Now, those are available free of charge, as we've shown you tonight, Form 214, 215, METARs and TAFs, from the Met Office Aviation Briefing Service, which is completely free of charge to register for and to use. And that's what we should be using to go flying on. Yes, apps are very nice to look at, but I always tell people when they come along to weather school, an app is great for seeing what the weather perhaps may be like possibly in 5 days' time. It's pretty good for using if you want to know whether you can hang your washing out or not. But actually, for us to go flying on, you should not be using phone apps and the weather forecasts from phone apps to be doing that. That shouldn't be happening. You should be using the proper regulated information. We know then it's up to date. We know that it's been produced by a human forecaster who's got all the necessary qualifications that they need. And we know that it enables you to be legal to fly with. And just something else here as well. When you're using your phone apps, when we're using many of these phone apps, they are just data pulled purely from a model and regurgitated to show themselves on a screen. If you did the job that I do every day as a forecaster, you would realize how inaccurate, or rather how much the model data changes from run to run of the model. Use the regulated MET products, use Form 214, 215, and the METARs and TAFs, and you're not going to go far wrong.
Lovely. Thank you, Simon. I did not know that about the model runs. We've put some useful links in the chat box for you for the Safety Sense leaflet and for the Met Office. So please feel free to avail yourself of those as you see fit. Right. Thanks ever so much to Matt and Simon. We have 10 minutes left, so it'll be over to you for Q&A. We've got some questions in the chat box already. We had a couple, in fact, we had one sent in prior to this event. So I'll go with that one first, if I may. And this one's going to be for you, Simon. This is from Gareth, and he asks how troughs of low pressure form and what its method is for producing weather. So ultimately, how do low pressure troughs form? How do they produce weather, and how they dissipate, and how long they last? So all about troughs.
Okay, all about troughs, right? So we'll keep this relatively short. This is something that we cover in detail at Weather School. It's something that pilots often ask about. So not surprised we've got this one first up. So a trough, when we see a trough marked on a 215, or even on just a surface weather chart, you'll see it as a solid black line, a bold black line. And think of a trough as an area of intensified showers. So it's pretty much like a cold front. It's an area of instability, and when we think of instability as pilots, we should think of convection. Convection is large cumulus and large cumulonimbus clouds, and it's cumulus and cumulonimbus clouds that produce showers. So a trough is an area of heavy showers. Now, what you'll find with a trough is that very often the bases are relatively low, and kind of I use these rough guesstimates of a base of sort of 1,500 to 2,000 feet if a trough is precipitating, tops of 20,000 feet plus, because there will be QNIM there. Obviously, day to day, there'll be a big difference in those cloud heights, but that's what I have in the back of my mind. Heavy showers and thunderstorms along trough, not a good area for pilots to be flying within. I would not be flying within a trough. It's not a good area. Gusts, you've got hail, we've got icing, and we've got thunderstorms in there as well. So the best thing to do is, if you see a trough approaching your airfield, just wait it out. Let the trough pass through, and then as the trough has passed, conditions will often improve. And to the rear of the trough is a decent place to go flying. There may be some more showers coming in, but they won't be as intense as they would be along the line of the trough itself. And again, as a very rough figure, think of a trough usually as about 50 nautical miles across. That's normally the width of a trough, there or thereabouts. As I say, it's a very rough figure, but if we think of it within those terms, we're not going to be a million miles off. Don't go flying them is the trick. And if you see them marked on the chart in Europe, particularly in the summer months, don't get caught out, because they can look like very innocuous features, but sometimes the tops on those QNIMs in the summer months over Europe can be over 40,000 feet. I ain't going flying anywhere near them. I don't know about you.
Fair enough. Thank you, Simon. Right then, on to another question. This one's from John. Any advice to predict sea fog at a coastal airfield?
Sea fog, coastal airfields. Okay, depends on where you are. Across western and southern coasts of the UK, western coasts of France as well, southwesterly wind, always key. That southwesterly can bring in what we call a tropical maritime air mass. Remember your air masses from your PPL days. Well worthwhile reviewing those. But effectively, southwesterly wind, very often moist, mild air mass, that can bring in sea fog. Watch your temperatures and your dew points at those airfields. If the dew point suddenly starts to get close to that temperature, that's an indication that we may well find sea fog forming. Also, another tip for being at a coastal location with an airfield, if you are, let's say, just on top of a cliff over higher ground, and perhaps you've got a wind that's coming from inland, but it's forecast to change direction and come off the sea, as the wind hits the hills or the cliffs, it will rise, the air will rise over those cliffs. That forced rising may just cool it sufficiently to enable sea fog to form. So always look for that breeze off the sea. A westerly, a southwesterly wind over western and southern coasts of the UK or like I say, western parts of France, over eastern coasts of the UK. And we may see this next week, the winds coming in from the east or the northeast, always a sign that we're going to get reduced visibility, reduced cloud bases, and those hazy winter days.
Lovely, thank you. Another one for you, Simon. Matt, I'm afraid you've not got much say tonight.
Sorry, Matt.
Simon, please explain the difference between cloud-based and ceiling. And that one's from Peter.
Okay, so a difference between cloud-based. Cloud-based is what we get even if we've got 1/8 of cloud. You know, there's forecasters, we measure cloud in eighths, so we call them octaves. So even if we've just got the smallest amount of cloud, whatever that the bottom of that cloud is the cloud base. Now, ceiling refers to greater than that. I've got to remember the figure. I think it's 4/8. So it's broken and above cloud. So anything above broken, so broken or overcast cloud, that's what we call ceiling. So I think it's 4/8 and above. Do you know any more about that, Matt? I think it's 4/8 and above. It's broken and above, isn't it?
Yeah, it's broken and above.
Yeah,
View doesn't count.
Yeah, so it's a measure of kind of if you've got a decent gaps between the clouds, the ceiling is considered to be above. But if we've got a fair amount of cloud with a little bit of blue sky in between, that's the cloud ceiling.
Brilliant, thank you. Well, another one, we've got a bit more of a regional question here from Sean. Any special advice for Scotland? Mountains, very few TAF and METAR station, HARS, etc.
Wow, where do you start with Scotland then? There's so much going on there. Okay, so Scotland, big one for turbulence, for mountain waves, for wave cloud generally, is warm sectors. So between warm fronts and cold fronts, you get a stable layer of air there between those two fronts. They can often produce a lot of turbulence off the mountains there. Showers in Scotland, heaviest of the showers always going to come in on a polar maritime air mass, so from the northwest. You can get some snow down eastern coast in an Arctic maritime air mass, which comes in from the north or the northeast. HAR coming in off the North Sea, easterly winds always are likely to be producing that coming in from the east across Scotland. And yeah, I think wow, that would be a whole session to cover Scottish weather. But what I would say, right, with Scottish weather is, again, and I keep banging on about this, I know the textbooks are really dull at teaching this stuff, but try and learn your air masses. So get your air masses absolutely cracked. We've got a little pictorial guide I was just looking at here that we do at Weather School for air masses, and break them down into easy to use what the air mass is, what the cloud base is, etc., what the cloud tops would be in each individual air mass. And if you can nail your air masses and nail the weather that comes with them, you're going to be so far into forecasting the weather yourself. So basically learn your air masses, I'd say. Important for Scotland, important for everywhere else.
Chris, I'd like to pick up on the one question from an anonymous attendee there about Prob 40s and Prob 30s. And I'd be interested to hear Simon's view after this as well, because we had this very debate at one operation where I fly with certain limits for flying air cadets, and there is a view that you can ignore Prob 30s for the limits and things like that as well, because I understand this is what a lot of commercial operators do. So if you're in your 777 coming back, and that you can ignore a Prob 30, say for your factoring or whatever like that as well. So, you know, I'd be interested in Simon's view. We had very mixed opinions, actually, on whether we need to take into account Prob 30s or not. I mean, from my view, again, you know, going back to my Oxford example, it was that Prob 30 of the fog coming in at Oxford. Prob 30 of your crosswind going out of what your aircraft can take. Don't know, question. Be interested in Simon's view.
So if you just see my heart rate there, Matt, you'd see it start to rise at that question, because every time it gets me. Okay, Prob 30s, Prob 40s. From a forecasting point of view, that there are specific definitions according to the World Meteorological Organization, and of course they define what Prob 30, what Prob 40 is for ICAO. So we have strict definitions as forecasters as to what they are. However, right? I don't think we need to even go into that, because as pilots, what do? A TAF is valid for a specific airfield. So it's for that actual airfield. And then as pilots, we go off in our aircraft to find those Prob 30s or Prob 40s, whatever they may be. So, you know, if you've got, let's say, a Prob 30 of thunderstorms at the airfield, that's only for that airfield. But then we get in our aircraft and we start flying around trying to find that Prob 30. Well, that increases the probability anyway. So what I always say to people is, if you see a Prob 30 or a Prob 40 on a forecast, as far as the forecaster is concerned in the back of their mind, the Prob 30 generally means that the situation it has the potential to occur. I think that's the best way to put it. Has the potential to occur. The probability is there. The Prob 40 means that potential for it to occur has been increased even further. So it's always a tricky one, but I always say to people, you do not under any circumstances ignore a Prob 30, because the forecaster has put it in there for a reason. If he or she didn't think it was going to happen, they just wouldn't put it in there at all. It just wouldn't be mentioned. So for me, for pilots, for GA, you know what, roll the Prob 30 and the Prob 40s all into one. It means that there is a chance of that significant phenomena occurring. And yeah, there may be slightly different interpretations from forecaster to forecaster, but Prob 30, Prob 40, don't get hung up on it. There is a significant chance that could happen. Just think of it, if given the same synoptic situation, 3 times out of 10, that situation will occur, or 4 times out of 10, that situation will occur. It is still a significant risk.
Okay, lovely, thank you. We have still a handful of questions, but we have come to time, sadly. So what we will do is we will take your questions and provide a follow-up article on our website. I've got to get my money's worth out of Simon, get his work rate up. So we will endeavour to answer those questions for you and provide details back on the website. So thank you for that. I'm just going to skip through those slides and move on to this. Right, so remember to check out our website, please, and the links to the resources we spoke about today, some of which have been in the chat box. In particular, the 214 and the 215 that Simon's spoken about, the Met Office Aviation Briefing Service, which you can see on the screen there, and the Met Office Pilot Resources. Okay, you can also access a replay of this workshop again on our YouTube channel and website, etc., in case there's anything you'd like to revisit. And as I say, we'll provide a follow-up article to answer the questions that we haven't got to today, so apologies for that. One thing I have taken away from today definitely is the appetite for people to get stuck back into the weather, Simon. So I think it sounds very much like we're going to have to do a follow-up session, maybe another session on weather. Maybe we'll look at the let's get stuck into those air masses, because I think that's probably a really good place to start. So look out on the website for more details on that. We have also going to add links to the Skyway code, which has obviously got a useful bite-sized section on the Met in there, and also the updated CAA Safety Sense leaflet, which is in the chat as well, on winter flying. That's all of that stuff we're going to stick on the website. So please do visit the website, Astral Aviation Consulting .com, and there's the details on there. You can also follow us on the socials as you see fit if you're that way inclined. We have some other stuff coming up. We've got another workshop in February, I think, and we're going to start looking at human factors. And then we're going to do another one, I think, on return to flying again early in next year. So please sign up for those, please. Again, you can contact us through the website, or you can sign up to our mailing list, which is actually the best way to get most up-to-date information. Looks like we'll be feeding in another weather school one as well. Right then, let's talk about Simon's stuff just at the end here. If you do feel like you want to brush up on your Met knowledge, then please do contact Simon through his website, www.weatherschool.co.uk. He runs a number of different courses, and webinars. And in fact, the next course is running, you can see on the screen there, is in February. So if you are interested and you feel like you need to brush up before the flying season begins in earnest, then please sign up to that. Again, you can also follow him on all the socials you can see on there. Okay, I'd just like to close now with a final thank you to Simon.
Pleasure.
I won't take your anarachness offense by your anarachness.
It's mine, it's all mine.
Yes, I absolutely love the way you just happen to have a air mass chart down here and then just pulled it up. So Simon is the weather man. So brilliant. So thanks ever so much to Simon. Again, thank you ever so much to Matt for providing the context on the practical aspects of the weather. And I hope all of you managed to take something useful away from this. And judging by the amount of stuff that's gone in the chat, thank you for that. The stuff that's gone in the Q&A box, it looks like everyone's been really engaged. So really appreciate that. So a final thank you from me and good night.